In this lesson, I'll show you how to common factor expressions containing fractions. In question 1, we're expected to factor 7ab over x plus a squared b over x squared minus 8ab squared over x cubed, and then check your results. To common factor expressions containing fractions is very similar to common factoring a regular expression. The top part is the exact same, so pretend that there was no denominators in any of these terms and factor it as if you would factor any expression. That is, what factor is in common in each of these numerators? We have an a here, here, and here, so we can pull out 1a. There's a b in common in all three terms as well. This leaves us with 7ab has been removed. Technically, we've divided out ab plus a, this b has been removed, minus 8, a has been taken out, b. This is over x, this is over x squared, and this is over x to the power of 3. We're not done. Now we have to worry about the bottoms, the denominators. Unlike the numerator, factoring out the denominator is different. When we factored out a and b, we looked for the smallest degree in each of these terms. The opposite is true for the denominator. We look at the largest degree. This is x to the power of 1, this is x to the power of 2, and this is x to the power of 3. So I'll factor out x to the power of 3. If I factor out x to the power of 3, this x goes away, and we're left with x to the power of 2 at the top. I'll explain why in a moment. Here, this x to the power of 2 goes away, leaving us with simply x. And over here, this term will not have any more x's. So our final expression, factored, is ab over x to the power of 3, 7x squared plus ax minus 8b. Now the reason why we chose the highest degree is, take for instance 7 over x, which was this term before we factored out x to the power of 3. When you common factor, what you're technically doing is dividing out that factor from that term. So if I divide this by 1 over x to the power of 3, I'm left with 1 over x divided by 1 over x to the power of 3. We take the reciprocal of the second fraction, 7 times x to the power of 3 over x times 1. This cancels out with one of these, leaving us with 7x squared, which is what I wrote. Now, had you not pulled out x to the power of 3 and pulled out only x, the lowest degree, you'd be left with terms containing fractions. To check your answer, you multiply this factor into the terms within the brackets, and you should end up with exactly what you started with. Let's go ahead and figure out question 2. We'll factor out the numerators, just like how you would normally common factor an expression. The smallest degree for the x's in all three is 1. For the y's, it's also 1. And z is only found in this term, not in the other two, so we can't factor out a z. At the bottom, the largest a is a squared, and the largest b is b squared. This leaves us with x to the power of 2, we don't write the y, over, we don't write down any a's here, but we will write down a b. And at the bottom, you don't need to include anything. Let's just place a 1 there. Minus 1x has been removed, and 1y. And at the bottom, 2 a's have been removed, so we don't need to write down anything, and 2 b's have been removed. This is the only thing we write. And finally, for our last, we have 1x and 1y removed, and the z remains. Since I pulled out 2 a's, we're left with 1 at the top and 1b at the top. You don't need to write down anything below. This is your final answer, and just to show you what it would look like without these fractions, it would look like this. Of course, you can check your work by multiplying this factor into these three terms, and I can assure you, you'll end up with what you started with. Finally, in question 3, there's nothing factorable in the denominator, but in the numerator, there's an x and b in common. The highest degree for x is x squared, so I'll write down 1 over x squared. The reason why I put down 1 is because nothing was factorable in the numerator. And the highest power for b is b squared. I'll rewrite my numerators. And my denominators we write down an x beside the 3 and a b beside the x. For this term, we write down an x beside the 1 and nothing else, because b to the power of 2 over b to the power of 2 is 1. And for this w, we don't write down any x's, but we do write down a b, because this x squared and this x squared will cancel out. B to the power of 2 over b is b. And there you have it. 3 examples on how to common factor expressions with fractions.